OSPF network LSA or LSA type 2. In this video, I am going to talk about the LSA type 2. You know that in previous video, we have learned about LSA type 1. Here we have exactly the same scenario, but I'm going to change this scenario a little for talking about the OSPF network LSA or LSA type 2. Let me to review the first scenario. After that, we can start talking about the LSA type 2. Here we have again the similar scenario R1, R2 and R3. You know that here we have only one area. This is a single area 0 or area quad 0. R1 connected to the router 2 with one point-to-point links, and also R1 connected to router 3 with one point-to-point links, and also the R2 connected to the router 3 again with one point-to-point links. Actually here we have only point-to-point links and also the Ethernet links without any neighbor. Actually all of these neighbors, you know that all of these links, you know that are the stop links. Okay, you have learned about the stop links in the previous video. Now I'm going to change a little this scenario. Let me to show you what is happening when we are adding one broadcast network to this scenario. For example, one network with DR BDR election. This is the next step. Okay, here assume that we are removing the link between the router 2 and router 3. Let me to shut down this interface in the router 2. I'm going to shut down the interface serial 11. Okay, and also in the router 3 again conft interface serial 11. Okay, shut down. Now we can remove this link between the router 2 and router 3. Instead of this link, we can add one switch. This is our switch, and let me to add one new router. This is our router. Okay, and after that we can connect the router 2, router 3 and router 4 to this network, and after that we will have one broadcast network with DR BDR election. This is the router 2, then router 3. Okay, let me to show you. This is the for example router 3 connected to this switch, and finally the router 4 connected to this switch. Actually now we have a broadcast network. Also let me to add another switch here. Okay, this is the LAN connected to the router 4. I am going to show you why we need to another type of LSA, for example the LSA type 2. Okay, this is our new scenario, and here we have this range 10400/24. Okay, and the link between the router 2, router 3 and router 4, this segment is using for example another range. Here we can use for example 172.16.10/24. Okay, and in the router 2 we are using 0.2. In the router 3 we are using for example 0.3. Okay, and also in the router 4 we are using the 0.4. That's it. Okay, also let me to configure the router 3 as the DR. The DR is not important. Okay, one of them should be DR. Let me to configure the router 3 as DR. For example, router 2 as the BDR, or router 4 as the DR other, because I'm going to show you what is happening when we have one single area network with both stop networks and also transit network. We call the broadcast networks with DR BDR transit network in the LSTB or link state database in the OSPF. Okay, assume that this is the BDR. We will configure it, and also here we have DR other. Okay, how we can configure it? It is so easy. Let me to configure first the scenario here in the router 1. Okay, this is in the router 2. This is the router 2. First we need to add this interface. This is the fast Ethernet 01. Okay, let me to add fast Ethernet 01. Here we have this interface. Let me to write here fast Ethernet 01, and also this is fast Ethernet 01. Okay, and here we have this interface as fast Ethernet 01, and the interface connected to the switch 4 as the fast Ethernet 00. Let me to reset the labels again. Okay, yes, this is fast Ethernet 00. Okay, as you can see, let me to use only these options. Okay, let me to configure them. It is so easy. In the router 2, we need to add interface fast Ethernet 01. IP address is 172.16.12255.255.255.0. Then no shutdown. This is the first command. After that, in the router 3, let me to configure interface fast Ethernet 01. IP address is 172.16, okay, 13255.255.255.0, and then no shutdown. And finally, now we have a new router, router 4 should configure with the interface fast Ethernet 00, IP address 172.16.14255.255.255.0. Then no shutdown. After that, interface fast Ethernet 01, IP address is 10.4.0.4.255.255.255.0. Then no shutdown. Now let me to configure OSPF on the router 2. On the router 2 we have configured before OSPF, but now we need to configure the fast Ethernet 01 as the BDR. For example, we can configure IP OSPF priority 15, okay, in the router 2, and then in the router 3 IP OSPF priority 100. And in the router 4, okay, over the interface fast Ethernet 00, IP OSPF priority 0. Okay, then we can enable OSPF on the router 2's interface, IP OSPF 1 area quad 0. Then in the router 3, IP OSPF 1 priority, IP OSPF 1 area again quad 0. Okay, and finally in the router 4, we can configure first router OSPF 1, okay, then router ID quad 4, then network 10.4.0.4 quad 0 area again quad 0, and finally network 172.16.1, for example 4 quad 0 area again quad 0. Now we have this new scenario. I'm going to talk about the scenario, but before talking about the detail, let me to show you the neighborship tables that we have in this scenario, starting from the router 1. This is the router 1. Show IP OSPF neighbor. As you can see, we have two neighbor, router 2 and router 3. It is okay. In the router 2, let me to show IP OSPF neighbor. As you can see, we have three neighbors, router 1, router 3 and router 4. Okay, we should wait some second. After some second, here we will have the neighborship, the full neighborship. Now look at here, the router 1 is our neighbor on the point links. The router 3 and 4, both of them are our neighbors, okay, in this segment. The router 3 is the DR, as you can see, because of its priority, and we have the state of full with the DR. And with the router 4, because it is DR other and router 2 is BDR, again we have the state of full adjacency, and also the priority of router 4 is 0. It is okay. In the router 3, let me to check the neighborship table, show IP OSPF neighbor. Router 1 is our full neighbor because we are connecting to router 1 in one point links. Router 2 is the BDR, and again we have full neighborship with the router 2 because of its priority. And then with the router 4, we have full neighborship. The router 4 is DR other, and the priority of this router, this interface, is 0. Then in the router 4, show IP OSPF neighbor can show us we have two neighbor, router 2 and router 3. Priority of router 2 is 50, priority of router 3 is 100. We have full neighborship with both of them because router 2 is the BDR and router 3 is the DR. Okay, this is our new scenario. Now I'm going to talk about that what is happening in the topology tables. Okay, first about the R1 LSA type 1, you know that we don't have any change because in R1 nothing is changed. Because of that, we can say the LSA type 1 of R1 exactly is the same LSA before we had, okay? But in the R2, we have some change. You know that in R2, we are sending RID is equal to the quad 2, and then R2 connected to the 10.120/24. This is one of the stub networks, and the cost of this network is, the cost of the connectivity is 64. It is okay. But you know that the R2 doesn't connect to the 10.230/24. Now let me to remove it. And also R2 connected to 10200/24 with the cost of 1, and this is one of the stub net links, it's okay. Also R2 connected with the 10122 interface IP address to the RID of quad 1, it's okay. But you know that the R2 doesn't connect with the 10232 to the RID of quad 3. Because of that, we should remove it. Okay, here we have some new information. Let me to write here the new information in the LSA type 1. You know that R2 connected to one transit network. In the OSPF database, beside of a stub network, we have another beside of a stub link, we have another link type. We call it the transit link type. This is a transit link type. Okay, this means that in transit link types we have DR and also BDR. We call them in the terminology of the link state database transit links. Actually, you have some links as stub links and some links as the transit links. Here you will see the R2, okay, with the interface IP of the 172.16.1.2 connected to one transit network. Okay, and with the cost of 1. Because of that, you know that here we are using the fast Ethernet, and fast Ethernet cost is 1. And also we have another information here. The new information is that the DRIP address of this transit network is 172.16.1.3. okay, here let me to review. We should send the interface IP address of router 2. Then we should say this is transit, not a stub, and the cost of our connectivity is 1. DR is 172.16.1.3. That's it. Also, let me to talk about the LSA type 1 of router 1. Okay, router 3. Router 3 says that RID, my RID is quad 3, router ID, and I am connected. I have connectivity to the 10.1.30/24 with the cost of 64. This is one of the stub links. It's okay. Also, you know that the router 3 doesn't have connectivity to the 10.230/24 now. Let me to remove it. Also, I have connectivity to the 10.300/24 with the cost of 1, and this is one of the stub links. It's okay. Then the router 3 says that with the 10.133 IP address, okay, I have connectivity to the router ID of quad 1. It's okay. But you know that the last line is not available now. We should remove it. Also, here we have one new line in the router 3. Let me to add it with the interface IP of the 172.16.1.3. okay, we have connectivity to the one transit network. Okay, after that with the cost of 1, let me to write here with the cost of 1, and also the DR of this network is 172.16.1.3. That's it. This is the information that we will have in the LSA type 1. Actually, now you can better understand the content of LSA type 1. Let me to write here. In LSA type 1, we have this information. For the stub links, okay, we have network address and also the mask and also the cost. This is the information that we have for stub links. Also, for point-to-point link, okay, a P2P link, we have this information with this interface IP. I am connected. I have connectivity to the neighbor RID. Also, we have cost. But for transit network, we have this information with this interface IP. Okay, we have connectivity to one transit network with this cost. Okay, and also DR of this network is the IP address is 172.16.1.3, for example. Here now you can see the information that we have in the LSA type 1. Also now we have router 4. You know that the router 4 should send its LSA type 1. Let me to show you. This is the LSA type 1 of the router 4. Okay, in the router 4 LSA type 1 we have this information. My RID is quad 4, that, and also I have connectivity to the 10.400/24 with the cost of 1. This is my stub networks. Also with the interface IP of 172.16.1.4, I have connectivity to the transit network with the cost of 1, and also the DR IP address is 172.16.1.3. Here now we have 4 LSA type 1. Why? Because we have 4 routers. You know that In one network, when you have 4 router, you will have 4 LSA type 1 in each router. Because of that, in the router 1, router 2, router 3, and router 4, you will have 4 LSA, okay, type 1 and receive from the router 1, router 2, router 3, and router 4. Okay, now let me to show you what is happening when we have only the LSA type 1. This is our topology. For example, assume that this topology is drawing from the view of router 1. You know that again we should review all of this information. For example, let me to start from the information or LSA type 1 of the router 2. Router 2 sent this information to the router 1. I am a quad 2, okay, and after that I have connectivity to the 10120/24 with the cost of 64. You will have this this information 10120/24 with the cost of 64. It's okay. And also I have connectivity to the 10200/24 with the cost of 1. This is a stub. This is okay. And after that, you know that here we don't have information about this link. Let me to remove it. Okay. And after that, here we have this information. I have connectivity to the router ID of quad 1, okay, with the IP address of 10.122. It's okay. And also I have connectivity to one transit network with the cost of 1 with this IP address, this interface IP address 172.16.1.2, and the DR of this network is 172.16.1.3. okay, because of that the R1 can understand that here we have one link. Okay, this is transit link, not a stop link. When you are talking about the transit link, means this link does not have only for example 2 side. Here we have more than 2 side, for example 3 side, 4 side. Here we have, for example, 3 routers working in this segment. Okay, and after that now we can understand that the cost of connectivity to this transit network is 1. This is the cost. Also, the IP address of the router 2 or quad 2 is 172.16.1.2. This is the IP address of interface of router 2 connected to this network. Also here we know that the DR of this transit network is 172.16.1.3. That's it. And now we have this information, this topology from the information received from the LSA type 1 of router 2. From the router 2, again, we have this information. My RID is quad 3, okay? And also I have connected to the 10130/24 with the cost of 64. This is a stop, this link. And also 10300/24 with the cost of 1, this link. And also I have connectivity to the router 1 with the 10133. It's okay. And also I have connected to one transit network, as you can see here, with the IP address of 172.16.1.3. Here we have 172.16.1.3, and the cost of my connectivity is 1. That's it. And also the DR of this network is 172.16.1.3. That's it. Also now we are receiving one new LSA from the router 4, from the quad 4 actually. Because of that we can assume that here we have one new router. This is the quad 4. Let me to add it to the topology. And after that, in this router 4, we have this information, LSA received from the router 4. I have connectivity to 10400/24 with the cost of 1. Okay, it's okay. You can add this link here, and the IP address of this link is 10400/24. The cost of connectivity is 1. After that, as you can see here, we have the next line. I have connectivity to one transit network with cost of 1 with this interface IP, and the DR is 172.16.1.3. That's it. This means that now the router 4 also is connected to this transit network. Okay, this is the router 4, with one link connected to this network. Okay, and also the cost of connectivity is 1 again, and the IP address of the router 4 is 172.16.1.4 connected to this network. After that, also the DR of this network is 172.16.1.3. That's it. All of this information, okay, are gathering from the LSA type 1, only received from the router 1, router 2, and router 3, and router 4. But here we have some miss about the information, some information that we need them. Okay, for example, you know that here we don't know the mask of this network. For example, the mask of this network maybe is /16. /24, /25, or some other things. One of the things that here we don't know about that is the range of, or is the subnet of this link. Also, you know that in OSPF, okay, we are implementing the SPF over the LSTB. Let me to write here. In OSPF, when you have LSTB, you are running the SPF directly on the LSTB. Okay, let me to say that in the LSTB we can only inject, okay, the point-to-point links, means the links with two head. Okay, for example, R1 connected to R2. Okay, but in the real world, as you can see, we have some links with multiple head. For example, one head connected to router 2, one head connected to router 3, one head connected to router 4. We cannot inject these type of links to the LSTB, and SPF cannot run over these links. Because of that, you know that in multi-access networks, we are using the concept of pseudonode. You have learned about the pseudonode. Let me to show you. Assume that in this network we have one pseudonode, and this pseudonode actually is the DR. You have learned about the DR. You know that all other routers should exchange with the DR only, and DR should send the information to other routers. Actually, here we have one pseudonode. Okay, let me to write here. This is our pseudonode, and we are using it for propagating the information to other routers. You know that in transit network, okay, we are using the pseudonode for propagating the information. Actually, this pseudonode is the DR. Let me to write here, okay. And after that, as you can see, after using this DR, beside of the benefits related to lower resource usage that I have explained in the previous video, we have this possibility, okay, to using these multi-access networks, to injecting these multi-access networks into the LSTB. Okay, in LSTB we cannot inject directly one multi-access networks, but with DR now we have multiple point-to-point links, okay, multiple two-head links. And let me to say that in DR, okay, in this mechanism, the DR cost to all of these links are 0. Because of that, injecting this DR doesn't change the cost between the router 2 and router 3, router 2 and router 4, and router 4 and router 2 and router 3. Because of that, we can say we are injecting DR without change, okay, in the cost of the physical network. And this is only one imaginary, for example, router. Why we should add it? This is virtual router, because we want to reduce the resources of in propagating of the link state, and also we want to inject this part of network into the LSTB. And in LSTB we can inject only two head links. Because of that, we are using the DR. You have learned about the DR functionality in previous video. Now you can see another function of the DR about the injecting of multi-access links into the LSTB. Because of that, now we have a DR. But the question is that how this DR, okay, is created, is injected to the, for example, LSTB of all routers. We need one router to inject this DR to the LSTB of other routers. And this is the function of the LSA type 2. We need another type of LSA, okay? This type of LSA, it does not need to send from all routers. Only one LSA type 2 is needed. Let me to show you the content of LSA type 2. The first thing that you should know is that the name of LSA type 2 is network LSA. You know that the name of LSA type 1 is router LSA. You can say router LSA means LSA type 1, or you can say LSA type 2 or network LSA. Both of them are same, okay? But in the information that we have in the LSA type 2, we don't have any, for example, line about the stub networks, point-to-point network, or some other things. Here we have only two parts of information. First, the mask of network, and also the attached routers to this network. For example, in this scenario, the mask of this network is /24, okay, and also the attached router to this transit network is quad 2, is quad 3, okay, and also is quad 4. The next question is that who should send this LSA type 2? The DR should send it. Because of that, here we have only one transit network, and the DR should create this LSA type 2, okay, the router 3, and send this LSA type 2 with this information. I will show you. In the LSA type 2, we have this information and also the DRIP address. DRIP address is 172.16.1.3. Actually, the DR says that I am 172.16.1.3. I can give you this information. The mask of this, for example, transit network is /24, and the attached router are quad 2, quad 3, and quad 4. And after receiving this LSA type 2 from the router 1, from the router 2, from the router 3 and router 4, they can draw this topology, exactly this topology, okay? The router 4 thinks it connected to one router, and the name of this router is DR, for example. You know that actually when we are talking the DR, this is the router 3 working as a DR. You can assume this topology. Let me to show you. You can assume this topology. Okay, both of them are same, but in most cases you see this for example topology in the references, but it is okay. Okay, now let me to show you the content of the network LSA in our scenario. But you know that before showing you, let me to review some of the show commands. You know that with show IP OSPF database, we can see, we can verify, we can watch all of the database or LSTP. With show IP OSPF, okay, database, we can monitor the database, and also after that you can use one of these two options and also other options. Router means please show me or LSA type 1. Network means please show me or LSA type 2. You know that when you have 4 router, you will have 4 LSA type 1. Means 4 router LSA. When you have 1 transit network, you have 1 LSA type 2. In this network, because we have 4 routers, we will have 4 LSA type 1, and also because we have 1 transit network, we have only 1 LSA type 2. Okay, after that, about the for detail of one specific LSA type 2, you can use show IP OSPF database network, then LSA ID of the LSA type 2. LSA ID of the LSA type 2 is DRIP address. You know that LSA ID in the LSA type 1 is the advertiser router ID. For example, the LSA ID of the LSA type 1 advertised from the router 1 is quad 1. The LSA ID of LSA type 1 of the router 2 is quad 2. Okay, and the LSA ID of the LSA advertised from the for example router 3 is quad 3. Okay, let me to write here. And then from the router 4 is the quad 4. And now about the LSA type 2 that the router 3 is advertising, the DR is advertising, we can say the LSA ID of this LSA is 172.16.1.3. This means that if you want to see exactly this LSA type 2, okay, you can use show IP OSPF database network 172.16.1.3. That's it. Let me to monitor the link state database or LSTB. Let me first show you the LSA type 1, because in LSA type 1 now we have some change. Starting from the router 1, okay, this is the router 1. You know that the database of all routers are same, show IP OSPF database. This is the router 1 database. Then in the router 2, show IP OSPF database. In the router 3, let me to show you, show IP OSPF database again. And finally in the router 4, let me to show you, show IP OSPF database. As you can see, we have similar information on all routers, as you can see. Okay, and here we have 4 LSA type 1 in the router 1, 1 LSA type 2. Here we have 4 router link state and 1 network link state. It is okay. In the router 2, again we have same 4 router link state and 1 network link state. In the router 3, again we have 4 router link state and 1 network link state. And finally in the router 4, we have 4 router LSA and 1 network LSA. Now let me to show you the content of the LSA type 1s. First, in router 1, show IP OSPF database. You can use each router that you want. Show IP OSPF database router, for example, means LSA type 1, quad 1, LSA of the router 1. Here we have this information, the information received from the router 1. We don't have any difference between this information and the previous video, but let me to review them here. We can start from the information of the LSA type 1 of router 1. As you can see here, you can see this line. With the 10131, I have connectivity to the quad 3. This is this line, 10131 to the quad 3. Then I have connectivity to the 10130/24 with the cost of 64. Let me to show you this line. Okay, after that, this is a stub network or a stub link. After that, with 10121, I have connectivity to the quad 2. Okay, a 10121 connectivity to the quad 2. Then here, as you can see, I have connectivity to the 10120/24 with the cost of 64, this line. And after that, here you can see I have connectivity to 10100/24 with the cost of 1. That's it. Okay, now let me to show you the content of the LSA type 1 received from the router 2. Show IP OSPF database router quad 2. Okay, here we have these four lines. First, I am the router 2 or quad 2. Okay, after that, here you can see we have connectivity to one transit network, this line, with the router interface address 172.16.1.2, DR is 172.16.1.3, and the cost of our connectivity is 1. That's it. Here you can see all of this information. Okay, after that, you can see again I have connectivity to the 10200/24 with the cost of 1. This is one of the stub networks. Let me to show you here 10200/24. It's okay. Then here you can see with the 10122, I have connectivity to the quad 1 with the cost of 64. It is okay. Here you have this line. After that, again, with I have connectivity to the 10120/24 with the cost of 64. It's okay. This line. Then let me to show you the information received from the router 3, show IP OSPF database router quad 3. Look at here again. With the 172.16.1.3, this is my interface IP address. I have connectivity to one transit network with cost 1 and also with the designated router of 172.16.1.3. Actually, you are monitoring these links, this line. Okay, after that, let me to show you the next line. I have connectivity to one stub network. The IP address of this stub network is 10130/24, and the cost of our connectivity is 1. So easy. Look at here. This is this link 10330/24, 10300/24, cost is 1. Then with the 10133, I have connectivity to the router 1, to the quad 1, this line. Okay, and after that, we have connectivity to the 10130/24 with the cost of 64, this line. Actually, as you can see, we know everything. And in the router 4, let me to show you the information received in the LSA type 1 of the router 4. Here we have only two links. First, with 172.16.1.4 interface IP address, I have connectivity to the one transit network. The DR of this transit network is 172.16.1.3, and the metric of our connectivity is 1. That's it. Here you can see this information. Also, as you can see, I have connectivity to 10400/24 with the cost of 1. And now we know about the detail of all LSA type 1. Now, let me to show you the detail of LSA type 2. Show IP OSPF database. You can use show IP OSPF database, then network. Okay, after that 172.16.1.3. That's it. Here we have only this information. The DR IP address means link state ID is 172.16.1.3. This is the address of designated router, means IP address of the designated router. Also, you know that the router ID of the advertiser router is quad 3. Okay, but the LSA ID is the router is the DR IP, not DR ID. Then here you can see the network mask is /24, attached router quad 2, quad 3, quad 4, exactly this information. Because of that, now we know why we need to LSA type 2, because we should create one virtual router in mind in the topology of other routers, okay? And because of that, we need one, for example, LSA type 2, and you know that LSA type 1 should be sent from all routers in one area, but LSA type 2 should be sent only with the DR. The number of LSA type 1 equal to the number of routers in one area. The number of LSA type 2 equal to the number of transit network. For example, here we have only one transit network, we have one LSA type 2. If you have more than one transit network, you will have one LSA type 2, okay, for each of the transit networks. This is the next step. Now you can understand why we need LSA type 1, why we need LSA type 2, okay? In the next video, I'm going to add another option to this scenario. You know that until now we have learned about the single area design with only point-to-point links and also point-to-point and broadcast links means with a stop and also transit links. But now I'm going to add the next option, multi-area of OSPF design. In the next video, we will learn about what is happening when we have more than one area, for example, two area. Okay, after that we can better understand the functionality of the different LSAs in the OSPF. In the next video, we will learn about the OSPF LSA type 3. We call it summary LSA. This is so interesting. Okay, you know that each router only should have only the topology of its area, but it should know about other areas, not the topology of other area. Only the network addresses are available in other areas. You will learn about them, but now it's your time to reviewing the LSA type 2. You should exactly such as me draw this topology, and after that think this topology, to these LSAs, and after for example understanding everything, you can understand the next step, the LSA type 3. Because of that, after reviewing the topics in this video, after verifying the database or LSDB in all routers, please come with me to the next video. We will talk about the OSPF summary LSA or LSA type